Now we take a look at operations with functions. So if we stick with the idea that functions are a literal set of directions, we should be okay. We're just going to follow certain steps that are happening, and as long as we follow them exactly as we're supposed to, everything should work out just fine. All right, down here we have our functions that are defined. We've got one called h of x, which is x plus 1. Another one called g of x, which does x squared, right? And then down here we have our set of instructions that we're supposed to take the input -1 and put it into the g function. And over here, this is a little different. Well, we're supposed to take the input 2 and put it into the h function. We're also supposed to multiply that function h by 2. All right, that's what this means. So let's take a look at how this plays out. So g of -1, actually, let's start this a different way. G of -1, well, g does x squared, so -1 squared goes there, plus 2 times whatever h of x is. Well, h of x is x plus 1, and we're supposed to put the number 2 into h of x. So there it is, 2 plus 1. All right, let's sort out the rest. And -1 squared becomes +1 plus 2 times, well, whatever's in this bracket, which is 3. So we get 1 plus 6, and the result is therefore going to be 7. Right, so what I did is just follow the directions that that I was asked to follow given the defined functions. We'll take a look at an example where we have no direct input values given. In other words, the input value is just the variable that we started with. So let's see how this works. And what we're basically doing here is combining functions together, arguably to create a new function, but we just want to follow the directions. That's what we're doing in every step of functions, is following the directions to see what the result is. So I'm supposed to take h of x and subtract 3 times g of x. Okay, so let's take a look and see what that appears as. Well, h of x, the instructions are x plus 1. And let's get rid of that line, it's a bit confusing. All right, and we're supposed to subtract 3 times whatever g of x is, which is just x squared. Okay. So as we move from there, well, x plus 1 and minus 3 times x squared is minus 3x squared. There it is. And on our last line, we just combine anything we can, and there's nothing to combine, so the answer is okay as it is. Usually in math, people write the highest exponent first, followed by the variable, followed by the number. So that means -3x squared plus x plus 1 plus 1 should be the result of what we have. We continue operations with functions now, looking at what happens when you multiply functions together to get again, it's arguably a new function. You could give it a new name. It depends on the context, but let's keep things simple here. We're just looking at what happens when you multiply p of x by r of x. Well, p of x is the instructions x squared, and r of x is the instruction x. When the two are multiplied together, we could just use the exponent laws to add the exponents. So x without an exponent has the exponent 1. X squared multiplied by x, those are the exponent laws we practiced in the foundational review. We add them when they are the same base, and there we go. That's it. Same idea happens when we divide functions. So we're just following instructions. Now we're asked to divide p of x by r of x. So that means p of x, which is x squared, divided by r of x, which is just x. And again, we can use the exponent laws and subtract the exponents. 2 minus 1, we're left with just x. So the result of p of x divided by r of x is x. The next degree of difficulty, I'm not sure that it's much more difficult, it's just a little different, is that we're going to take the result of one function and we're going to substitute that as the input to the other function. So this is a bit different than what we were doing above, but not that different. We're still just following a set of instructions, and it's really important to understand that we take g of -1 and use it as the result of that as the input to the function f. So let's see how that works. A couple of ways I'm deciding on how to explain this. So I think the first way, for simplicity, what I'm going to do is I'm going to take a look at, so this is just a little side note, g of -1 is, well, g is supposed to do x squared, so g of -1 is -1 squared, which is +1. That now becomes the input for our function f. All right, so f of 1 would be, well, that should be 1 plus 1, based on f of x being x plus 1. So the result is 2. So that should be the end result for what we have over here. Now let's see, how do we do that all in one step? Okay, so given that f is composed of g of -1, okay, so g of -1 is going to be -1 squared, but we're going to be putting that inside of f of x. So I'm doing the exact same thing as I did over on the right. I'm just going to do it all in one line. So f of x is usually x plus 1, right? But we're going to do it a little different. Instead of the x plus 1, we're going to have -1 squared, right? Because that's what's supposed to go in for g of x, and then plus 1 right there. So we've got -1 squared, which is +1, plus 1, which equals 2. We get the exact same thing. Now, at this point of working with functions, it doesn't really matter whether you do it separately as two steps like we did over here on the right, or whether you combine them as one. I would like you to get this idea on the left-hand side. All right, so just going over that one more time. G of -1 is what goes into f of x wherever there's an x value. So we took g of -1, which is this, and we put it in for that x value, and the rest of what we're doing is adding 1 to it, and once we do, we get a result of 2. So I'm doing a new question now, g of f of x. I'm going to reuse those same functions that I defined above. All right. Sorry about the mess, but here we go. So f of x is still x plus 1. G of x is still x squared. So the instructions down here are take f of x as the input to g of x. Okay. Well, g of x does x squared, and f of x is x plus 1. So what I'm going to do here is take x plus 1 and put it inside g of x. G of x was x squared, so in place of x, we have x plus 1. All right, from there, the calculation is not too bad. That's just x plus 1 squared, which looks like that, and we get x squared plus 2x plus 1 once we FOIL it out, right? And that's about it. It doesn't look like we've done much because we didn't have inputs, but we've actually created a new function that graphs completely different to either f of x or g of x. As we move towards more concepts in calculus and so on, you'll see where this links up and relates. One final note before we wrap up the functions unit. There's two different types of notation that you might see with composite functions. So I'm just making a note that this is the same as this, at least how they function. So they look different, but they operate the same way. The one on the left means take f of x and use it as the input for g of x, just like we've been doing above. And it's read g of x composed of f of x, right? And the one we've looked at a lot on the right-hand side is that f of x is the input to g of x, works exactly the same as we've done above. And I think that should be enough information for you to be able to make your way through this worksheet.